Hello everyone, welcome back to Math with Allison. Today we're working in our integration series, so we're going to be talking about integration by parts and how we use it repeatedly. So let's go ahead and dive into it. Here we have what we usually like to see with integration by parts. We have x times cosine of x dx. We set u equal to something that disappears, aka when you take the derivative, it will become a constant. And we set dv, equal to the leftovers. So let's go ahead and work it through this problem just as a nice introduction. So here we set u equal to x because when we take the derivative of x, we just end up with 1 times dx. Now we set our leftovers equal to dv, so we get cosine of x dx, and we're going to go ahead and integrate both sides. So this is how we get our v, and that is equal to sine of x. So now how I remember integration by parts is UV rays shooting at voodoo. So we're going to go ahead and see what that looks like worked out. So we have UV, x times sine of x, shooting at voodoo. So we get sine of x times dx. And remember, the purpose of integration by parts is to get the integral down to something that we can just easily take the antiderivative of. So the antiderivative of sine is negative cosine of x plus c. So that's what we like to see, personally, I like it. It works out nicely. But what if we had two things that are just kind of circular? The derivative of e to the x and the integral of e to the x is always going to be e to the x. Sine of x is going to go in the sine cosine circle, positive or negative. And so both of these are kind of circular in that sense. So let's go ahead and talk about how we can use integration by parts to actually solve for this integral. So just choose something that you set u and dv equal to and stick with it. I'm going to set u equal to e to the x, and I'm going to set dv equal to sine of x dx. And you could have, of course, switched those because usually people like to differentiate sine and cosine rather than integrate because things get backwards in our heads sometimes, and that's okay. So whatever your heart desires. So I get du is equal to e to the x dx, and I get v when I integrate both sides. V is equal to negative cosine of x. So let's set up integration by parts, uv rays. So we get negative e to the x cosine of x, right? That is that first multiple minus the integral of v du. So that becomes a positive cosine of x times e to the x dx. So here we did one step of integration by parts. Like I said, we're going to do this multiple times. So you choose something and you stick with it. We chose that u is equal to e to the x and that dv was equal to the leftovers. So here dv is going to be equal to cosine of x dx. So let's go ahead and go through this. We get du is equal to e to the x dx. And when we integrate both sides, we get v is equal to sine of x dx. So we have what our integral is equal to. I'm just going to copy paste it. Okay, I just copy pasted that first part. Plus, and now what we did was integration by parts on that second integral. So here we get uv rays, so e to the x times sine of x, shooting at voodoo, and there's no negative to cancel that out. So we get sine of x times e to the x dx. Do you notice a similarity between the integral that we just got and the integral that we're differentiating? They're the same integral. So what I'm just going to go ahead and do is add this integral over. And you can rewrite it because multiplication is commutative, right? Those two are equivalent to one another. So when I add that over, now I have two integrals of e to the x times sine of x dx. And this is equal to that whole thing, which I'm going to copy and paste. So how do I solve for the original integral? I just divide both sides by 2. So if I divide both sides by 2, I get e to the x sine of x dx is equal to, and you can either write that as negative 1/2, or you could write, divide the whole thing by 2, but I'm just going to write it as 1/2. And then don't forget to add on your constant of integration for your final solution, right? And that right there is how we can use repeated use of integration by parts. It's kind of circular, if you like to think about it that way. But we're going to go ahead and try one more example because it gets a little more difficult when constants are involved. Let's go ahead and switch it up. I'm going to set u equal to sine of 6 theta. And I'm going to go ahead and set dv equal to everything else. So we get e to the negative 2 theta d theta. Okay, so here we get du is equal to, that becomes 6 cosine of 6 theta, just using chain rule, d theta. And when we integrate both sides, we get v is equal to negative 1/2 e to the negative 2 theta. So let's go ahead and set up this first one. So we have our original integral, which I'm going to copy and paste. This is equal to uv raised, so we get negative 1/2 e to the negative 2 theta times sine of 6 theta minus voodoo. Okay, so here we can, if you wanted, you could bring out that constant multiple immediately. So that's become plus, and that becomes 6 divided by 2. And inside we get e to the negative 2 theta times cosine of 6 theta, d theta. And of course we can go ahead and rewrite this, so that becomes a positive 3 on the outside. Okay, so we chose something, we're going to stick with it, we're going to do it again. So here I'm going to go ahead and set u equal to, and this time cosine of 6 theta. So that way dv is equal to e to the negative 2 theta times d theta. If you wanted, you could include that constant somewhere in there, or you could leave it on the outside, whatever your heart desires. So here I get du is equal to negative 6 sine of 6 theta, d theta. Working into that v space, but that's okay. Negative 1/2 e to the negative 2 theta. And here we're going to go ahead and do it again. So I'm going to copy and paste this part because, you know, it doesn't change at all. And this is where we cannot forget that constant of 3. So first we have 3 times uv raised. So that becomes times negative 1/2 e to the negative 2 theta cosine of 6 theta. I'm going to zoom out a little bit. Whew. Okay, and then again, don't forget that 3. So, but we're going to do minus voodoo. So 3 times the integral of v du. So that becomes negative 1/2 e to the negative 2 theta times negative 6 sine of 6 theta d theta. Look, this is taking up my whole page. So let's go ahead and simplify this down with our, there's lots of constant multiples here. So I copied and pasted the first part, and then that becomes negative 3/2. And now, oh gosh, okay, so we have 3 negatives there, so that means it's going to stay negative. And then we have that 1/2 simplifies down with 6 to be 3. So we just have 3 times 3, which is equal to 9 times the integral of e to the negative 2 theta sine of 6 theta d theta. So this is what I mean with constants. It gets a little cluttered, but you know, one step at a time. So we did it twice, and this is where we need to check that this integral that we have left over is equal to our original integral. And in this case, that's totally true. So let's go ahead and add it over. We're going to add over 9 times that integral. Okay, so we have 10 times our integral of e to the negative 2 theta sine of 6 theta d theta, and that is equal to the leftovers on the right side that we, didn't change at all. And so our last step is to divide everything by 10. So we get the integral of e to the negative 2 theta d theta, sine of 6 theta d theta, is equal to, if I divide everything by 10, that becomes negative 1/20 e to the negative 2 theta sine of 6 theta minus 3 divided by 20 e to the negative 2 theta cosine of 6 theta. And that right there, once we add our constant of integration, is our final solution. So just be careful with scalar multiples. Go through it one step at a time. As you can see, there's a ton of algebra involved, and then the integration by parts is the few steps of calculus that we do. But that's all I have for us today in this video. If you enjoyed it, I have many more like it, so make sure to check out my playlists. They're linked down below. Otherwise, please give this video a thumbs up and comment other problems or topics you'd like to see done. Thanks for watching.